Dear students, we were discussing about chemical kinetics. Chemical kinetics deals with the rate of a chemical reaction, and by altering the conditions, how to get maximum yield. All those things we are going to discuss under chemical kinetics. That's what we were saying. Now, regarding instantaneous reaction, that's what we were discussing. Instantaneous reaction, instantaneous rate and average rate of a reaction. What is the difference? We started to discuss even in the earlier class. What is it? With the example of cyclopropane getting converted into propene, CH2 is cyclopropane. When it is heated, it becomes propene, CH3. It is said to be a reaction of cyclopropane to become propene. This reaction we have started yesterday at about 780 Kelvin. This is what happening. All right. For this reaction, they given a table of column, and once again let me discuss about that. Time at the start of the reaction, the concentration of cyclopropane, that is reactant, concentration of reactant at the start of the reaction in minutes, 0 minute, nothing has happened, just we have started the reaction. At that time, the concentration of cyclopropane is found to be 2 mole per liter. Let me write mole per liter here. After say 5 minutes of time, the concentration might have been reduced. Since cyclopropane becomes propene, and therefore the concentration of cyclopropane is 1.67. At 10 minutes, it was found to be 1.4. At 15 minutes, it was found to be 1.17. At 20 minutes, it was found to be 0.98. And 25 minutes, it was found to be 0.82. And 30 minutes, after 30 minutes, the concentration reduced to 6.9. Slowly, after a very long time, the concentration might have been reduced to 0. All right. Now, if we find out the rate of reaction at a particular instant, that is at the start of the reaction, let me say at the start of the reaction, when the concentration of cyclopropane is 2 mole per liter, what would be the rate? That means the change in time interval, dt or delta t, whatever it may be, is approximately equal to 0 with no time gap. At the start of the reaction, when the concentration of cyclopropane is 2 mole per liter, what would be the rate? At what rate it might have been converted into propane? That is said to be instantaneous reaction, that to initial rate. Instantaneous reaction if it is calculated at the start of the reaction. If we calculate instantaneous rate at the start of the reaction, suppose if we mix 2 or more components, immediately after mixing, if you start to find out the rate, that is said to be initial rate. So how to calculate that? It may not be calculated, since it may be calculated within a range. We can find out rate within a range. Rate is equal to change in concentration divided by time interval. Likewise, we can calculate that is not instantaneous, that is average rate. 30 minutes time interval. Change in concentration, decrease in concentration, therefore minus 0.69 divided by 2, which is equal to minus 1.31 divided by 30, which is equal to 1.31 divided by 30 mole per liter per second, which comes to 4.4 something like that, into 10 power minus 2 mole per liter. This is average rate. The rate we have calculated for a range of 30 minutes, or when the concentration changed from 2 to 0.69. That is average rate. The average rate may also be calculated within a shorter period, 10 minutes at the start of the reaction, or between 20 and 30 after some time. At the start of the reaction, if you find out this average rate, it will be faster, and if you calculate here, it will be slower. Let us check rate towards the beginning. Again, average rate only we are calculating. Average rate towards the beginning, average rate for a wide range, average rate towards the beginning, 10 minutes duration. What is the change? 2 1.4 minus 2, minus 0.6, minus into minus becomes plus 0.6 divided by 10. So it is 6 into 10 power minus 2 mole per liter per second. Mole per liter per second. Likewise, average rate, if I calculate here, average rate, what will be the average rate? Definitely it will be lower, because as time passes on, concentration get reduced. Therefore, rate will become smaller. So what is happening? 10 minutes duration, dt is 10 minutes. Change in concentration, dA or D of cyclopropane, that is reactant. What is the change? 20, 0.95, 0.69. The range is 0.95, 0.69. Difference will be 6, and then 0.26. So minus of minus 0.26, 0.26, which is equal to 2.6 into 10 power minus 2 mole per liter per second. So we have calculated rate over the entire range, not entire range, up to 30 minutes. Average is 4.4. At the start of the reaction, if we take average, within first 10 minutes, it is 6. It is little bit higher. After say 20 minutes, little bit lower. So this is how, as time passes on, the rate will be lowered. Rate will get reduced. And therefore, we want to calculate rate at a particular concentration. Say, when the concentration is, say, 2 mole per liter for cyclopropane, that is at the start of the reaction, what would be the rate? Definitely, it will be higher than this. It is average of 30 minutes. It is average of first 10 minutes. If we go in for still at the beginning, the rate will be definitely higher than this. And if we calculate rate at after 30 minutes, that is when the concentration is 0.269, it will be definitely lower than this. Likewise, we can very easily find out how. This can be calculated only from the graph. We have to draw a graph taking concentration of cyclopropane in y-axis and concentration of time in x-axis. Likewise, we can draw a graph, and the graph that is drawn can be shown. It is found in your book, page number 208. This is the graph. Let me roughly draw, but the data I am going to take from the book. All right. So, concentration of cyclopropane. Cyclopropane, if it is written within square bracket, what does it mean? Cyclopropane, if it is written within square bracket, it is said to be concentration of cyclopropane. It has to be written like this. And here, time in minutes, because it is given in minutes. All right. So let the graduation be from 0. Concentration 0, 0.5, 1, 1.5, 2. Likewise, it is given. Because we have concentration only up to 2. And time, approximately, let us go up to 100 minutes. 10 minutes, 20 minutes, 30 minutes, 40, 50, 60, 70, likewise it goes. If we draw a graph, what is happening? If we, at 2, what is the time? 0. The surface will be here. When the concentration become 1.6, time may be 5 minutes, it will be here. Likewise, if we draw a graph, more or less you will be getting a graph like this. As time passes on, the rate will be slowly going down. Only at infinite time it will become 0. Concentration will become 0 only at infinite time. Therefore, it will go very slowly. Suppose if we want to calculate, it is 2. Therefore, approximately it touches here. Concentration 0. All right. So, if we want to calculate instantaneous rate, we have to draw a graph at that concentration. For example, 2 means at 2 we have to draw a graph, draw a tangent for the curve. If I want to calculate at 1.5, again I have to draw a tangent at this point. If we want to calculate at 1, tangent at this point. All right. Likewise, if we calculate tangent, if we calculate slope of the curve at that particular point, that will give the initial rate. Instantaneous rate at the start of the reaction, that is at concentration 2 mole. And at different concentrations, I can calculate instantaneous rate. Instantaneous rate, if it is calculated at the start of the reaction, it is said to be initial rate. And any particular instant, that is after 15 minutes, or when the concentration become 1, Likewise, at so many stages, I can find out instantaneous rate. What is the rate at the present condition? When the concentration has become 1, what is the rate? When the concentration becomes 0.5, what is the rate? Likewise, I can calculate. If it is calculated at the start, it is said to be initial rate. So that can be, how can we calculate, as I explained now? We have drawn a curve based upon these points. We have plotted a curve. And at any particular concentration, we can perform a tangent along the curve. And the slope of the curve, how to calculate slope of the curve? See, let me take only at 20. This is at 20, let me say. At 20. The curve, these 2 points will give the distance in y-axis, the distance in x-axis, dy by dx will be the slope. At any particular point, if we draw tangent, that will give, the slope of the tangent will give instantaneous rate. All right. Likewise, in the graph, a graph is given here. You just look at here, because for me it is difficult for me to draw. I can take this graph. You just have a look. If you have a book, you can have a look. First slope is drawn here. All right. The tangent is drawn here. And at 2, I can make any point. See, it may be between 1 and say maybe 2 and 1. If I draw a slope for this, it will be 1, concentration is 1, and the time interval comes to 10, 15 approximately time interval 15, and the change in concentration between 2 and 1. So change in concentration 1 mole per liter divided by time interval 15 minutes. See, this is the tangent. Hope you can see clearly. Or else you have the book, no problem. 2 and 1. Change in concentration 1. And the time interval approximately, this is the time interval. This is the tangent. So 10. If it comes, it is 15 approximately, not exact. So if 1 is divided by 15, what will be the value you will be getting? 6.6. Am I correct? 0.06. 0.06. Again 6, 7, like this it go. Approximately, this is approximate calculation. I made 1, I made 15. So that the value is 6.67 into 10 power minus 2 mole per liter per second. So actual calculation they have made, it is found to be 6.92. Yes, 66.92. I made approximate one. It may be little bit lower. It may not be 15 minutes. It may be little bit 14 minutes like that. And that we have to see exactly. Likewise, when the concentration is 1, again they have plotted a tangent for the curve. This is the curve. When concentration is 1, this is the curve. This is the tangent for the curve. Again I can make how? This difference I can take. It is just 0.5. And the line is this one. This is the line. What is the change in time interval? It is 0.5. And here it is, sorry. Now I have to take like this then. 0.5 means from this point to this point, and then from this point to this point. All right. So what is the change in concentration? 1.5 difference 0.5, approximately 0.5 I made. This and here it is approximately 20 minutes, 10 minutes, 10 minutes, 20 minutes. This is the graph. This is the what is it? No, this one and then this one. Yes. So it is approximately 10, 13, likewise it comes 13 minutes, this to this, 10 plus 3 approximately 13 minutes. So approximately this one, 1 by 26, maybe 0.04, something like that comes. Actual value they given, yes, 3.46 into 10 power minus 2 mole per liter. Likewise, the last tangent is drawn here when the concentration is at 0.5. This is the tangent drawn here. For that also you can find out the slope. It is found to be 1.7. So it is quite obvious that as time passes on, the instantaneous rate, we are following instantaneous rate at concentration 2, at concentration 1, at concentration 5, at that particular instant. When the concentration is 2, that particular instant it is the rate. When the concentration becomes 1.5, the rate is found to be this much. When the concentration becomes 1 and then 0.5, it is for 2 mole per liter, it is for 1, it is for 0.5. They have made these three. So based upon the data, we can say that rate is going on decreasing. Average rate may not be suitable to find out correct rate. At any particular instant, we have to find out rate. That is possible by drawing graph, and at that instant by drawing tangent, and the slope of the tangent will give the rate. All right. So that is about instantaneous rate and average rate. Now let us go into rate law and rate constant. All right. What is rate law and rate constant? So same illustration we will be taking again. So these data we need. That's why I given elaborately about the reaction of conversion of cyclopropane into propene by heat. All right. Now, what is rate law? An equation relating rate of a reaction with concentration of the reactants. For example, for the reaction, say XA plus YB, XA plus YB gives products. I wanted to use same notation, X moles of A combined with Y moles of B to give product. For this reaction, what will be the rate? As per law of mass action, rate of a reaction is directly proportional to the product of the active masses. Active mass of A is square bracket A, that is molar concentration. This is the rate law that we can theoretically derive. It may not be always true. Sometimes we will be saying the mark scored by a student depends on the duration of time utilized for studies. It may be true partially, may not be always true. Why? They may be studying only for fewer hours or fewer minutes, but they can thorough with. Why? They are learning with concentration. Full attention is to learn. What is it? They will be going deeper into the subject, not just as studying the definition for marks, not like that. To understand what is chemical kinetics, what is rate, what is instantaneous rate, what is average rate, I should know fully. So they should go deeper into that. When I go deeper into that, I never forget. I need not study. I can explain to anybody and I can write in the examination also. So those students within shorter duration they will be studying. When you listen to the class perfectly and try to understand, if you have doubts, if you are able to clarify the doubts immediately, you can learn within. Likewise, here usually persons will be saying rate is directly proportional to concentration of the reactant. Since X moles of A are present to the power X to the power Y, it may not be true. When we analyze the experiment, it need not be to the power of X, it may be to the power of M, it may be to the power of N. M and N need not be equal to X and Y respectively. It has to be determined only by experiment. So rate of the reaction may be directly proportional to concentration of A to the power m and concentration to the power B to the power n. It need not be to the power of x and y. So it is the equation we have derived from experiments that cannot be theoretically given. Theoretically, I have started to give x and y. That may be wrong. In many occasions, that is found to be wrong. Few may be saying, but just by outlook, I will be predicting the person. No, we cannot. So they will be talking in a very sweet manner, so we may believe, start to believe, but the entire character may not be so. So it has to be experimentally determined. Rate is equal to rate constant to concentration of A to the power m into concentration of B to the power n. The power m and n together is said to be order of the reaction. So order of the reaction is the sum of the powers of the concentration terms in the rate law. That is said to be order. Order with respect to A is m, order with respect to B is n. So the order of each component in a reaction has to be determined only experimentally. For example, in the reaction of cyclopropane, in the conversion of cyclopropane into propene, the data, once again, let me go into the data. What is it? The data we have seen. When the concentration is 2, rate is found to be 6.92 in 10 power minus 2 mole per liter per second. When the concentration is 1, when the concentration of cyclopropane, it is rate. Again found in page number 208 only. Same thing we have seen just now. Mole per liter. When the concentration is 0.5, it is 1.73 in 10 power minus 2 mole per liter. All right. Now, what is the rate? What is the rate of the reaction? Rate of the reaction is equal to rate constant into concentration of the reactants. Here we have only one reaction. What is the reaction? A gives product. In the case of cyclopropane, what is the thing happened? It is cyclopropane, only one component gives propene. So A give product, that is a simple thing. So rate equation may be rate is equal to K into molar concentration of A to the power, we may not be knowing, it may be 1, maybe 1. So I think it is M, let me say M. Only one component, therefore I have written only M. Two component means I would have written B plus B to the power n, likewise I would have written. So rate is equal to K into molar concentration of reactant to the power m. Here the reactant is cyclopropane. We have taken the reactant cyclopropane. Alright. So what will be the rate constant or what will be the order? Let us see the order of the reaction. Order of the reaction m is equal to find out that what is the rate. Rate of a reaction at different time intervals we can find out. When the concentration is 2, what is the rate? Rate is equal to 6.92 into 10 power minus 2 when concentration of A is 6.92 into 10 power minus 2 to the power we may not be knowing. To the power we may not be knowing. Alright. Rate is equal to 6.92 when the concentration of let me write in the other way. So what is the rate constant here? Rate constant K is equal to, so let me give, it is here when the concentration is off, rate is also off. When the concentration is off, rate is again off. So it is very obvious it is first order reaction. That can be verified. How? Rate when it is 6.92, the concentration is 2. Again table column found in the book I am just referring. 3.46 into 10 power minus 2. How? Rate, concentration. K is equal to rate divided by concentration. Rate is 6.92 in 10 power minus 2. Concentration 2. So when you divide, you will be getting this value. And when the concentration become 1, what is the rate? That rate is 3.46 in 10 power minus 2. What will be the rate constant then? Rate constant K is equal to 3.46 into 10 power minus 2. That is the rate. That is the rate. What will be the concentration at that time? 1. Therefore, if we divide, again it will be 3.46 in 10 power minus 2. Again, third time we are going to calculate rate constant. Rate, what is the rate when the concentration is 0.5? When the concentration is 0.5, rate is 1.73 in 10 power minus 2. If we divide 1.73 by 0.5, again you will be getting this value 3.46 in 10 power minus 2. Here the rate is 1.73. So rate of the reaction varies with concentration. Rate of the reaction decreases when the concentration decreases, but the rate constant is a constant. So rate constant is a constant for a particular reaction, that you should know. Rate constant is a constant at a particular temperature. As long as you are not altering the temperature, by altering the concentration, rate may get altered. Rate will be getting altered, but rate constant remain constant. So the point to be known is rate constant is a constant at a particular temperature. All right. Now let me illustrate with one more example. Again, all those things are data are available, and only from the data I have to proceed. All right. So what is the another data? For the reaction, nitric oxide is oxidized to nitrogen dioxide. Nitric oxide NO is oxidized to nitrogen dioxide. For this reaction, three experiments were done with different concentrations of NO and O2. They arrived at the rate. When the concentration of nitric oxide is 1.3, of course into 10 power minus 2 mole per liter per second, that I need not, mole per liter. Concentration of NO 1.3 in 10 power minus 2 mole per liter. Concentration of oxygen 1.1 in 10 power minus 2 mole per liter. At that time, initial rate, instantaneous rate at the start of the reaction is found to be 19.26 into 10 power minus 2 mole per liter per second. Of course, unit for rate is mole per liter per second. Unit for concentration simply mole per liter. Here mole per liter per second. What is it? Rate. All right. When the concentration of NO is this much, when the concentration of O2 is this much, rate of the reaction is found to be initial rate. Again, concentration of NO is kept as such, and the concentration of oxygen is doubled, that is 2.2 in 10 power minus 2. When we double, the rate of the reaction is found to be doubled, 38.4 into 10 power minus 2. Again, they are keeping oxygen, concentration of oxygen constant, but concentration of nitric oxide is doubled. When it is doubled, the rate of the reaction is found to be 4 times of this, 76.80 into 10 power minus 2. All right. So now, how to calculate order of the reaction? Now, order with respect to nitric oxide, order with respect to oxygen, we have to calculate. How to calculate? So for that, let me rub this. Rate 1 is equal to rate constant is equal to into molar concentration of NO to the power m into molar concentration of O2 to the power n. We may not be knowing the order. We are going to find out the order, and let us find out the order. Whether you have 3 minutes already. Rate is equal to K into NO to the power m that is the rate law or rate equation. Rate of the reaction is equal to rate constant to the concentration of NO. We assume maybe square. Concentration of oxygen we assume maybe 1, but it is not sure, only experimentally we have to determine. All right, let us try to find out rate 1. Rate 1 is equal to, this one is equal to K into, what is the rate constant? Rate constant for this reaction, let it be K1 into NO. Concentration of NO is 1.3 into 10 power minus 2 to the power m into concentration of oxygen 1.1 into 10 power minus 2 to the power n. Again, what is rate 2? This is the rate 2. Rate 2 is equal to, rate 1 I can write 19.26 into 10 power minus 2. Here 38.4 into 10 power minus 2 is equal to K1. K, rate constant will be a constant always. So 38.4 for a particular reaction, rate constant is a constant. K is equal to into 1.3 into 10 power minus 2 into 2.2 into 10 power minus 2 to the power n to the power m. If it is 76.6, 76.8 in 10 power minus 2 is the rate, when the concentration of nitric oxide is 2.6 in 10 power minus 2 to the power m into 1.1 in 10 power minus 2 to the power n. All right. Now, if rate 1 is divided by rate 2, rate 1 is divided by rate 2. If we divide like this, what will be the value? It is rate 1, it is rate 2. If I divide, it will be 2, double, rate 2, rate 1, 2 by 1. It is equation 1, it is equation 2, it is equation 3. Let me divide 2 by 1. All right, it is at the numerator. Therefore, 2 by 1, it will be 2, it will be 2. K into, when I divide 1.3, it will be getting cancelled. If I divide, it will be getting cancelled, it will be getting cancelled, and 2 to the power n you will be getting. Am I right? K will get cancelled, this will get cancelled, it will be 2 power n. 2 power n is equal to this much. Therefore, n is equal to 1. So, order with respect to oxygen, this is oxygen, n is equal to 1. Likewise, if we divide 3 by 1, what I will be getting? It is 4 times. 3 by 1 is equal to 4 times. 4 is equal to this. These two will get cancelled. These two will become 2. 2 power m. 2 power m is equal to 4. Therefore, m is equal to 2. That means order of with respect to nitric oxide is 2. Order with respect to oxygen is 1. This is how we determine order of a reaction for different reactions. All right.